Okay, so what we're going to do next then is with these new functions that we're going to study here for the rest of this time, we're going to put a definition on here of this type of function, and it's called a sinusoid. Okay? And we say a function is a sinusoid if it can be written in the following form: a times sine of bx plus c plus d, where a, b, c, and d are all constants, and neither a or b are 0. And keep in mind, if a were 0 here, then we would wipe out the whole entire expression except for the d. So then it wouldn't be a sinusoid, it would just be a line, a horizontal line. And then notice b can't be 0 either because we'd wipe out the x. Okay? And again, we'd have a constant function at that point if we wiped out the x. Okay? So anything that can be written of this form is what we call a sinusoid. Now, I want to add something to that though. Okay? If it's of the form a cosine bx plus c plus d, this is still a sinusoid. Okay? There's no such thing as a cosinusoid. Fair enough? Okay? So either one of those, if it's written in any form of sine or cosine, then we call that kind of curve a sinusoid. Okay? It could be sine, it could be cosine. Either one qualifies as a sinusoid. Okay? All right. Now, as you already are aware at this point, without me having to tell you, the A, B, C, and D are going to cause some changes in what the graph looks like. Okay? And we probably already have a pretty good idea of what most of it does. Okay? All right, the simplest one would be the D. What is the D going to do for us? And it's going to go either up or down. If D is positive, it's going to make it go up. If D is negative, it's going to make it go down. Okay? How about A? It's going to be a vertical stretch. So remember how we go normally between -1 and 1? Okay, that's going to stretch it between something else and something else. Okay, maybe if that was a 5 out there, it would be -5 to 5 instead. Okay, and then the B and the C there both have a direct effect on X. B is going to be a horizontal shrink or stretch, and then C is going to be a horizontal translation. Okay, all right. So let's see how that's going to come into play with our graphs that we're going to study today. We'll start with the A value here. And we do have some specific words for some of these, really all of these, I should say. The amplitude here is the A value. Okay, whatever number is in front of the sine or cosine is your amplitude. Okay, if we're looking at just plain old sine and cosine, the amplitude is 1. There's just a 1 in front. Okay, and hence we go between -1 and 1 for our y coordinates. Now, when we actually present the amplitude, we want to make sure we present it as the absolute value. So we wouldn't want to say the amplitude is -5. That wouldn't make sense. Even if it had a -5 out in front, the amplitude itself is a positive value. Okay, and we would say the amplitude is 5. Okay, even if it were a -5 out in front. Okay, all right. And a couple of facts about the amplitude. The amplitude is always half of the height of the wave. Think about how that worked with the sine that we just drew. We drew a sine function that looked like this. It went between 1 and -1. Okay. What's the height of the wave from top to bottom? The height is 2, and the amplitude is 1. Okay. And looking at our equation for that, why also is the amplitude 1? Because what's in front? 1. Okay. All right. So as soon as we see a different number there in front, we know that it's going to stretch that thing up to whatever and down to whatever. Or if it's a half in front of there, then it would shrink it down to a half and -1/2. All right. We discussed this idea of period a minute ago. Okay. But what it boils down to is this is probably going to be, when we're trying to graph a sinusoid function, probably the most important part that we're going to have to handle is figuring out what is the period of the sinusoidal function. Okay. And the key is right here. Okay. It has to do with that b value. Whatever number is in front of x, that's going to dictate what the period of this function is. And if we know what the period is, then we can set up a coordinate axes and we can draw the function appropriately. All right. So what it boils down to is the period is always going to be the original period, which is 2 pi, divided by the absolute value of b. So remember with our sine function, okay, we said earlier the period was 2 pi, because what number is in front of this x right now? 1. So 2 pi divided by 1 is 2 pi. However, if we had sine of, let's say, 2x, okay, now our b value is 2, and so the period of this one would be 2 pi divided by 2, which is pi. Okay, and just as a quick aside here, if we're going to, just to know what we're going to be doing with that information, if I were to tell you to graph that right now, Okay, here's how we'd set that up. If I said I want you to graph sine of 2x, okay, this is the way that I recommend that you do it every time. Okay, whether it's sine or cosine, either way. Okay, find the period. Okay, whatever the period is. Okay, make 1, 2, 3, 4 tick marks. Okay, put the period on the 4th tick mark. Okay, do half of the period on the 2nd tick mark, a quarter of the period on the 1st one, 3/4 of the period on the 3rd one. Okay, that way you got it labeled properly. So I would do that the very first thing I do if I'm going to graph any sinusoidal function. Okay, I'm going to set up my x-axis. Okay, now you'll notice that again, this function could go on to any direction forever, but we're going to focus on close to the origin here, and then we can extend it. If it tells us to do 2 cycles, then we might draw another 4 tick marks and draw it twice. Okay, all right, so we're going to do that, and then what we're going to do next is we're going to look at the amplitude. Okay, and with the amplitude, we're going to look at not only that, but also if there's any shifts. Okay, in this case, there's no shifts, so we only got to worry about the amplitude. So that means I can set up my x or my y-axis also, and I can go -1 and 1. Okay, had that been like a 5, then I would have put -5 or +5, -5. Okay, now remember, what's nice is the general shape is not different. Okay, so normally the sine starts at the origin. And unless there is a horizontal shift, which there's not, there's no c value here. So unless there's a horizontal shift, we're still going to start at 0, 0. Okay? All right, and here's the good news. Okay? If we know what the sine function looks like, then we can draw this with ease, because we know that sine starts at the origin. It goes to the maximum at the 1st tick mark. For us, the 1st tick mark was pi/2, remember, the normal one. Okay? Then it goes back to 0, then it goes to -1, then it goes back to 0. So when we get done, had we been asked to draw that, there's 1 cycle. And again, could we draw 2 cycles if we needed to? Sure. We just make 4 more tick marks and draw another cycle. Okay. But that right there would be a good graph of the sine of 2x. Now, had there been a shift here, then maybe instead of starting at the origin, maybe it would have been shifted pi/4. We would have started here. Okay, and then we would have had to make 1 more tick mark to the right also. Okay. But again, start with the period. Get that part set up on your x-axis. Then talk about the y-coordinates because of the amplitude and the vertical shift. And then from there, you can worry about your starting point, whether there is a translation to the right or left or not. Okay, so we're going to see some more examples here in just a minute. About questions so far? All right, just another example here. In this case, I want to make sure we're clear on this. If we have sine of x over 2, make sure you understand that that just means 1/2 x. Okay? Because if you recognize that, then if I go 2 pi over 1/2, okay, what is the period going to be here? Okay. And notice that it does what we thought here. A fraction here, or a divided by 2, is going to create a horizontal stretch instead of a horizontal shrink like we had in the last problem. But watch this. When I draw the graph of this, 1, 2, 3, 4, 4 pi, 2 pi, pi, 3 pi, 1, -1, 0, 0, up to 1, 0, -1, 0. Okay, how does this graph look like compared to the one I just drew a second ago? Besides crappy art. Did I do anything different at all? Okay, so what makes this different? Okay, the fact that you set up the period right on the horizontal axis. Okay, but in terms of graphing it, did I do anything different at all? Okay. All right. Let's take a look. There's one other fact that you're going to be asked about here in your homework, and that's the frequency of a sinusoid curve. Okay, the frequency is ultimately the number of complete cycles the wave completes in a unit interval. Okay, so and notice that the frequency is just the reciprocal of the period formula. Okay, which essentially is just the reciprocal of the period. Okay, so if you know the period, you can find the frequency just by finding the reciprocal. Fair enough. Okay. All right. Now, let's do a couple things here. First of all, it says construct a sinusoid with a period of pi/3 and an amplitude of 4 that goes to the point 2, 0. So in this case, we were given some of the information, and our job is to write an equation. Okay. So let's see if we can do that. Now, before we do it, though, I want you to think about this. If I were to draw a picture of this, I know it has to go through 2, 0, so that's right here. Okay. So 2, 0 is right here. It's got to have an amplitude of 4, and it's got to have a period of pi over 3. Now, if you start out with your basic sinusoidal function, okay, let's start filling in some blanks here. So the first blank we can fill in is the 4, because that's the amplitude. Okay. And then the next thing we're going to figure out is how we're going to make the period be pi over 3. Well, we know that that's going to be some variation in b, and we know that 2 pi over b is equal to pi over 3. Okay? Because again, we know that 2 pi over b is equal to the period, and they told us the period. So with that said, we should be able to solve this equation for b. I would use the cross product property here. I'd go pi b equals 6 pi, divide by pi, and we get b equals 6. So that means I'd have a 6 here. Alright. I'm going to leave the C and D as they are for the time being. Okay? So right now I'd be able to take care of those two without too much trouble, knowing how to, the amplitude obviously is the easiest one because you just plug that right in, but the B value you actually have to find if you know the period. Okay. Alright, and then from there, I'm going to figure out how about this C and D here. Okay. So, just take a look. Alright, so we know that the graph contains 2, 0. Okay. So if we shift the function 2 units to the right, okay, wouldn't that right there do it? Because normally it starts at 0, 0, right? So if we want it to go to 2, 0, okay, then we would just shift it 2 units to the right. Okay, and instead of starting at 0, 0, it would start at 0, 0. Now keep in mind that we use the sine function here. Could we have done this with the cosine function? Could have. Okay. In this case, probably easiest with the sine since it goes through 0, 0. We just translate it 2 to the right to get it to go through 2, 0. And of course we can distribute that. I'm going to tell you right now that you don't have to distribute that. This right here would be totally okay. Okay. Matter of fact, I would probably prefer that b to be factored out of that as opposed to multiplied into it. Okay. That way we can see this. Okay. Not only can we see the b value, but we can also see what the translation is. Because if you look at it in this form, can we actually see the translation? What might we think if we saw this, that it's moved 12 to the right? Huh? Okay. Is it moved 12 to the right? Absolutely not. So that brings me to a point that if you have a problem like that, what are you going to have to do first here before you can talk about the translation? You're going to have to factor out, you're going to have to get the x essentially without a coefficient. So whatever number is here is going to have to be factored out of that expression. Okay. All right, questions so far? All right. Okay, I want you to look at page 392 next.